Hi, in this video I will introduce the concept of exchange particles. When a force acts between two particles, for example the electrostatic repulsion between two positively charged protons, how do the two particles transfer momentum to each other across empty space? The answer is that exchange particles move from one particle to the other. Allow me to explain with an analogy. Imagine two people standing on skateboards. One of them throws a ball across to the other. Both the thrower and the catcher will move backwards as a result of this interaction. This is similar to how two like-charged particles repel each other. One of the particles will pass an exchange particle to the other, transferring momentum and causing them to move away from each other. In the case of the electromagnetic force, the exchange particle happens to be a photon. What about particles with opposite charges? These are brought together by the exchange of a photon. One way to imagine this is for our two people on skateboards to throw boomerangs at each other, resulting in them moving towards each other. We've already met that the electrostatic force is mediated by the photon as an exchange particle, but the weak nuclear and strong nuclear forces also have exchange particles. In the case of the weak nuclear force, the exchange particle can take the form of a W minus, a W plus, or a Z0 boson. These particles have got mass, and in the case of the W bosons, they also have charge. They can only operate over extremely short ranges, about 0.001 femtometers. That's about 1,000th of the radius of a proton. The W bosons are particularly important in beta decay. The strong nuclear force has a couple of exchange particles too. The pion acts as an exchange particle for strong interactions between nucleons that hold a nucleus together. The strong nuclear force also applies between the quarks within nucleons, and in this case it is mediated by a gluon. It has been hypothesized that the gravitational force has an exchange particle called the graviton, but this has never been actually observed experimentally.
Thank you for watching this video from Cowen Physics. If you found it useful, please like, subscribe, and visit cowenphysics.com.